Okay, morning guys, and today we are going to do implicit differentiation. Implicit differentiation is differentiation used to differentiate implicit functions such as circles and ellipses. So, reading from your workbook here, we have we read that some functions are defined implicitly by a relationship between x and y, such as x squared plus y squared is equal to 1. So you are supposed to go and check on your own what implicit functions are. Make sure you understand what they are. Right, so to find derivatives for such functions, we differentiate with respect to x, and for the part of the function which is expressed as y, we differentiate as we would a composite function, bearing in mind that y is the function of x. Right, thus we find the derivative with respect to y and multiply the derivative with dy dx. We shall see what all this here means, okay? Right, we see that we have a function x cubed plus y cubed is equal to 6xy. So this is an implicit function. So we need to find the derivative of y with respect to x if x cubed plus y cubed is equal to 6xy. So the first thing for us to do is to differentiate as we would the left side and the right side. Sorry for that. So we find the derivative of x cubed with respect to x, and then of y cubed with respect to x, and then of this 6xy with respect to x. Right. Jale here, on the left side, re tla ba le derivative of x cubed e ba 3x squared. The derivative of y cubed, re nka y cubed ena e le composite function. Then we are going to differentiate y cubed as is and then multiply ka derivative dy dx. Right, e leng hore mo banang y, you're going to differentiate as you would normally, but then multiply by dy over dx. So then we have the derivative of y cubed is equal to 3y squared multiplied by dy dx. Okay, on the other side of the equation, we have 6xy. And these are two separate functions multiplied by 6. So if we take 6 out, we are going to we are going to find the derivative of x times y, and we are going to use product rule. Right, so using product rule, re ntsheditse x 6 ka ntle, re na le x and then multiply by derivative of y, e leng 1. And then because ke y, re tlo tla re thamisa y eo kang dy dx. So ke x times 1 times dy dx. Right. Ebe re etsa plus. Remember, it's product rule. Ebe re tla re y ena. And then we are going to multiply by the derivative of x. So we don't have to multiply ka dy dx because ke x. So ke y yane as is multiplied by the derivative of x, which is 1, and then we close the bracket. 1 ke 6. We have this 6 here. So this is the product rule right here. And then we have 3x squared plus 3y squared dy dx, and then eba 6 times x, okay, the one that we talked about here, 6 times x times 1 dy dx plus y. Right, because mona re dx, the derivative of x with respect to x ke 1, so 1 times y ke 1 y. Right, and then we have 3x squared ena plus 3y squared dy dx is equal to now 6 multiplies everything inside the brackets. So it will be 6x dy dx and then 6y. Right, and then afterwards we are going to now try to collect like terms so that we have variables with dy dx on the same side of the equation. So in this case, we carry this term to the other side by subtracting it, and we carry this term to the other side by subtracting it. So we are left with this expression. Okay, this expression. And then from here on, we can factor out from the right hand side, we can factor out dy dx. We are left with 6x minus 3y squared. So we have 3x squared minus 6y is equal to dy dx 6x minus 3y squared bracket. Now what we want to do is to have dy dx as a subject of the formula. Therefore, we are going to divide by 6x minus 3y squared on both sides of the equation, and this is what we have. Right, and you can simplify if you need to. You can simplify and factor out 3 and see what you're left with, and this is what it simplifies to. So this is implicit differentiation, but there are also shortcuts where you can use other methods to differentiate implicitly, and I will give you material to refer to for that extra work. So what we're going to do here is to try and on our own try and find the derivative of this function, and we shall go through it together. So you are free to pause right here and try to do this problem on your own. Afterwards we can continue with the video and check if you got the steps right. All right, see you in a minute. Okay, let's do it together. Right, so we are going to differentiate this side and this side. Remember, we are going to differentiate with respect to x. That's our main focus. Right, now, highly generally sign x plus y. What type of function is this? We're focused on the left side. You are right. It is a composite function. So we are going to let the inner function be u and find the derivative of the outer function. Right, let us start with the left hand side. Say you let u be x plus y in this case, and say this whole function was z. Right, then our z in the whole function would be sine of u. Right, so our du dx is equal to derivative of this one, it will be 1. Derivative of this one, it will be 1 leon. How it's with respect to y, it will be 1. But remember, because it's u, we are going to multiply that 1 by dy dx. Thank you. And then here we have dz du. Dz du, in this case, get derivative of sine u. Really, it's a derivative of sine ki cosine. So we have cosine u. So the derivative of the left hand side would be this multiplied by that. Okay, so let us quickly write it down. It will be 1 plus dy dx, right, which is equal to multiplied by cosine u. Cosine u is x plus y. Right, so we have 1 times cos x plus y e tla ba cos x plus y, right? And then dy times this, e tla ba plus cos x plus y dy dx. So we multiply cos x plus y, got the first term and then the second term, and this is what we have. So our derivative for the left hand side ke cos ke ngolla tlase monana because re tlo tla re etsa lena, right? Ke cos x plus y plus cos x plus y dy dx. Remember, dy dx multiplies the whole function, not the input. Not the input, the whole function. So is equivalent to derivative ya side. What type of function is this? How are we going to differentiate it? You are right, it's a product of two functions, therefore we are going to use product rule, right? So to find the derivative of the right hand side, we write y squared as it is and multiply by the derivative of cos x. Sorry, it's a my blurry. So we write y squared as it is and multiply by the derivative of cos x, which is sine. In fact, give minus sign. So the minus will be here and sine of x. Right. So if we what do we add? We multiply cos x as is and multiply the derivative here, y squared, which is 2y. And then because it's y, we multiply dy dx. So let us write this nicely. Let us write this. So we have negative y squared sine x plus 2y, which multiplies cos x, and then dy dx. Remember, we multiply this dy dx. So I'm going to write it here on the right hand side. With a collect like terms and simplify or factorize and simplify. Really, let me write it down. Minus y squared sine x plus 2y cos x dy dx. Right, we have this. We have this, and we want to collect like terms, simplify. I'll give you a minute to do that. Okay, let's check whether you got a similar answer. So be aware that there are different ways of attempting this. So you and I ended up here, and now from here onwards, what did I do? I have cos x plus y, this one, by adding it. And then we have 2y cos x dy dx, which is this one, by subtracting it. And then from here, gets a factor out dy dx, and I'm left with 2y cos x, and then minus cos x plus y.